All right, so welcome to lesson 9, and in this lesson we will be covering the Python library called Pandas, and I would say the most important lesson and library that you'll learn for your own research is actually using Pandas. So we've learned about various other types of libraries that you will most likely use for research, and as I mentioned before, NumPy, Matplotlib, and now Pandas are the ones that are very useful for research, especially for data science and many other applications as well. So as I mentioned, the most important one I would say is Pandas. And I think this figure kind of gives us a breakdown of when you need to do like data exploration in Python. You would use these three libraries. NumPy contains all your basic linear algebra functions, Fourier transforms, advanced random number capabilities. I showed you how useful the NumPy array is and different range functions for it, all the different capabilities, and it's a lot quicker than standard Python. And Matplotlib over here is basic plotting and library. Offers Matplotlib with complete 2D graphics and some 3D support as well. And Pandas, which is structured for data operations, manipulations, analyzation of data, rereading in data, sorting, filtering, cleaning up data, and statistics that you can apply on the data as well. So I would say this Pandas is the most useful tool you'll see in this lesson. So I'll definitely focus on trying to understand it as much as possible. Okay, so let's go back to this Excel spreadsheet we have over here, and this option to filter certain data. We could have done this with for loops and conditional statements, but it takes a bit of time and be messy, right? So Pandas has all these built-in functions and methods that can do it for you. All right. So to first use Pandas, you need to install it, but in most cases it's already pre-installed. If you are using Anacondas, then it is installed. Otherwise, you have to use pip install to install it. And to use it, like I've done before, just say import Pandas as PD. PD again is an alias, just a shortened name, just so Python knows what library you're referring to. And importantly as well, we have done various other data types like lists, dictionaries, and also the NumPy array. So Pandas has its own one called a data frame, and if you're used to R, it also has data frame. So a data frame is very powerful. It can store data in a versatile way, which is quite unique to Pandas. What is unique to Python. And it's very similar to a dictionary, and in a sense, it's you can say it's unordered. So let's first see how it works and what it looks like if we get data and put it in the data frame. All right. So previously, when we used group lists, if we take a group list, for example, data set we had before, get a group list and put the list inside the lists, we can put that group list inside a data frame. We would need to transpose it. This is a standard procedure if you are reading in a group list. Then what we're doing is we're giving each of those lists a name, column names, because Pandas data frame actually looks like almost like an Excel spreadsheet that you'll see. Then we're just printing it out, and then you'll see the result from that. Another way is actually use a dictionary, and the dictionary will specify the name of the column and pass it the data lists. As you can see, we've done before. And then you can pass the dictionary to the data frame. Here I'm just removing the index, because you'll see that the data frame comes with a default index, and then I'm just printing it out. Let's see what the results look like. So you can see what how data frame orders and structures the code, and it's quite nice way to view your data, because it looks like almost like an Excel spreadsheet, how it would look. And then this is what it looks like from a group list, and this is what it looks like from a dictionary. So you can obviously see that it is identical. It's just from the group list, it's a bit more complex. There's two lines of extra code you have to do, which is transpose the data frame as well as give the column names. So it's a bit easier to use a dictionary, and I definitely recommend using that. Here I just describe a few of the commands that I do. So because index was already part of this data, I don't really need it, because you can see that the data frame has a built-in index, and that tells us, what row we're looking at. So I actually want to just remove that, and to remove that, I use this drop feature. So I refer df is the name of the data frame that I created, and I call the function called drop, and then I want to drop the column called index. I want to in place true just means that making it I am doing a change to the original copy of the data, and this just refers to the column name, because the lesson will further on the lesson we'll discuss what axis refers to. So I won't actually comment on that just yet. So here this describes what I need to do. So yeah, so actually here it actually describes axis would refer to row, column would refer to one, axis one. So I want to remove a whole column, so I would refer to axis one. And here's an explanation of what axis does. It just allows you to specify if you want to modify rows or columns. All right, so most importantly, in data science, you're usually going to read in data. Most times you're going to read in a CSV file, Excel file, some sort of binary file. So for example, we can take in a CSV file here, and quite similar to how we've done before, we can read in, we say pd.read CSV, the name of the file, and read in the CSV file, and actually split it up for you. And Pandas does a lot of the filtering for you, unlike NumPy, we have to specify, the delimiter with a comma and everything else. So that's why using CSV or Pandas to read in data is a lot better and definitely preferable. All right, so what other things you can do? You can start doing something called EDA, which is exploratory data analysis. And we've discussed the basics of Pandas and data frame. So a pretty cool thing is, if you read in data, you can say print.info, and it actually gives you info of the data frame you have. So it tells you how many entries you have. You have 11 from 0 to 10. It tells you your data type. So age is integer, gender, country are strings. Strings and Pandas is referred to object. And they're also non-null. So it tells you if there are any null values or no values in there. And some memory usage, but that's not too critical. A very useful tool as well to use is Describe. So what Describe does is, for the data frame, the data that you're reading in, you just say Describe. It gives you the count, the unique values, the topmost values, the frequency, the mean, the standard deviation minimum, the quartiles, the different percentages, and the maximum value. So pretty much everything we did in the first lesson, this does for you quite easily, just in one line. So I definitely recommend, just when you're looking at data, first do this. First look at your data, see what you're reading in data is correct, and then you can do Describe as a check. Just some basic stats on the data. Yeah, so I just describe what include as well does. You can read through that. Adding data, so adding editing data. So you can drop columns, as I mentioned before. You can also add data to it. So if you want to add data, you can just have a list here and create a new one called index 2 and name the index with index 2. You can assign it there. To modify any data, you would use a lock and add commands, for example. So .at towards the .at for the first index for the age column, give it the value of age, and then you see that the value of 100, and you see that it was assigned there. So importantly, this will not actually change the original data, but only copy that you're currently working with. So that's quite important. If you try to change it directly without the .at, you'll get a warning pop up that says, you're trying to copy either a view, you're trying to change a view of the data frame, which is not ideal. Ideally, if you want to work with data, rather make a copy of it and then change it. So here I describe a little bit what between a view and a copy is. So a view is the actual data you're working with, and a copy is exactly what it describes, a copy of the original data. So always use a copy of the data. So that's as easy as just saying df2 equals d8, for example, or you'll just create a new name for it. All right, so if you want to specify or if you want to get specific data, for example, what if you print out the age column, I can do that quite easily. If I want to print out all three, I can also just specify the name and print that out. For a certain range, just like we did with lists and strings, you can do slicing, index slicing on a certain range. There's actually a default, commands, something called, if you use head and tail works in Pandas function just to get the top 5, and top 5 is if you use head, and tails if you see the bottom 5 values. I think it's 5 or 10, I can't remember. And then this one, if you want to filter out data, you have to use a greater than symbol. And this will actually create a list, or actually a data set of true and false, and we'll compare that, and you use that to actually filter out the data. So you can easily get, filter data for people above 35, just with this line and passing it into your data frame, and you'll get, the data out that you want. If you want to see age and gender, you can, as I've shown you before. And then the other command I mentioned earlier but haven't shown is a lock command, which is useful to give you direct access to specific rows or columns based on their labels. And there's a similar one called iLock, which allows you to access data based on the index ranges. So, for example, lock would be 1 and age. iLock would be 1 and 0. So I can just read through that if you want specific values. Filtering with multiple conditions. So like we did in the first lesson, if you want to create a filter, a variable that filters entire data frame when age is greater than 35, you can first, it will first give a single column. Then we apply it to the data frame. Now, what happens if you want above the age 30, a male and from South Africa? Well, all you do, you would use logical operators and say, okay, for age bigger than 5, gender, weight equals to male, country is equal to South Africa. Use that to filter your data frame, and you can get the same result that you saw before in the beginning. So to do that, you just use the ampersand for each new condition with brackets. Plotting, like we've done with Matplotlib, you can also plot, like you can do the histogram like we've done before. Just refer to the column you want, say plot.hist, and then number of bins that you want here as specified to. You can also reorder columns. if you want to do that. And then all you do is just say pop and insert to kind of reorder the columns. You can go through an example to see how that works. Sorting and grouping. If you want to sort the edge column in ascending order, for example, you can do it quite easily. So what I first did, I copied the data frame in the desired order. So that's actually one way. So df2 just becomes a copy of the data frame, or you can use pop and insert method. So if I say pop country, so I'm removing country and putting it in the country column, then inserting country column into the position of 0. And if I print that out, you'll see where it's supposed to be. All right, and then you can also sort values by age. Here, it's sorted by age if you want. And you can also do grouping, so men and women by the mean age. So first specify how I want to group. I want to group by gender. And then based on the age and gender, I'm getting the mean, and they can get the grouping for that. If you want to group by mean age, a group by the country based on the mean age, and then they get that. So very powerful tool. This is actually only just the early introduction to Pandas, but very useful for your research, as hopefully you were able to see. Thank you. That's the end of this lesson.